Thank you for joining this lesson. We're going to discuss probability number 21. The probability that Hilda, Lucy, and Caroline will be late for breakfast on any one morning are a quarter, a third, and a fifth, respectively. Using a probability tree diagram, find the probability that. Then the questions flow. Remember to subscribe to the channel and to also share this link with friends. We're going to begin by drawing a probability tree diagram for the information above. So we have the Hilda's case. I'm going to begin with Hilda being late and Hilda not lating for breakfast. So being late is a quarter for Hilda. That means not lating is 3/4. That is the probability. In the next bracket, I'll introduce the second individual, that is Lucy. Now for Lucy, we're going to have Lucy lating or Lucy not lating. Now, Lucy lating is a third. That means not lating is 1 out of 5. And for the same Lucy, which is an independent event, will also be the same whether Hilda had been late or not. So we can go again for Lucy and say Lucy being late is a third. Sorry. Lucy being late is a third. So not being late should be 2/3. Remember, in every bracket, the probability should add up to 1 because they are two mutually exclusive events. So this is supposed to be 2 out of 3 because the probability of being late is a third. The not late is 2/3. This one was a misinterpretation. Now, in the last bracket, we shall have the third individual, and that is Caroline. So for Caroline, she can either be late or not late. And being late is a fifth, which means not late is 4 out of 5. And using this bracket, it will still be the same. Caroline or Caroline not lating, 1 out of 5. So 4 out of 5. We can also have the same at this bracket, or not late, 1 out of 5. So 4 out of 5. And finally, we will have the same at this bracket, Caroline or Caroline not late. Late is 1 over 5. So not late will be 4 out of 5. 4 out of 5. Therefore, now we can outline all these possibilities at the end of each bracket. Now, we can have Hilda late, Lucy late, and Carol late. The next is H, L, C not late. We can have H, L not late, and C not late. The next is H, L not late, and C not late. Then here we begin with the H late, this one and this one not late. The next is H late, then this one not late, but this late. The next is H late, L late, but this not late. Then we can have not late, not late, not late, not late, all of them. So those are the possibilities. The first question is number 1 here. None of them will be late. So probability none of them is late will be this one. This is the only probability. These are all the outcomes are showing none of them is late. This one is showing all of them are late. So none of them will be late means 3/4 times 2/3 times 4 out of 5 following this last bracket here. 3/4, 2/3, 4/5. Therefore, this can simplify already. 4 and 4, 3 and 3, and we will get the value as 2 out of 5. As 2 out of 5. The next, Roman 2, is only one of them will be late. Only one is going to be late. So it can be either this case whereby it is only one of them is going to be late. It can be this case, only one will be late, whereby H is late, the others are not. Or this, or another case, so this is one of them, only one is late. It means probability, this guy is late, the others are not. Or this case, whereby Carol is late and the others are not. Or the other case is the case where only this guy is late. The Lucy is late, the others are not. So it's probability. This one late, but the others not late. Or probability, this is not late, this one is late, not late. Or probability, this is not late, this is not late, but this one alone is late. So those are the cases we are going to handle. So this guy being late is 1/4, and the others not late. So Lucy not late is 2/3. This other guy not late is 4 out of 5. Or this one not late, 3/4, but Lucy alone late at a probability of 1/3. The other one not late. Or finally, you can have Caroline being late alone. So Carol not late. This is Hilda not late. The other one also not late, but Caroline late at 4 out of 5. Caroline not late is 4 over 5. So Caroline late, sorry, alone late is 1 out of 5. So these are the computations we're going to carry out now. We can have some simplifications like by 4, 4. This is 2 out of 15. The next, this 4 and this 4, this 3 and this 3. So 1 out of 5. Or 3 and 3, 2, 1, 2, 2. So this is going to be 1 over 10. Going to be 2 out of 15 plus 1 out of 5 plus 1 out of 10. This is going to be 13 out of 30. So that is the probability that only one of them is going to be late. At least one of them will be late. At least one of them is going to be late. You know, there is the probability that none will be late. Now we want probability at least one of them will be late. At least one of them will be late. So it is all these cases except here whereby nobody is late. That means we can take 1 minus the probability none of them will be late. So it can simply be 1 minus 2 out of 5, which will give us 2 out of 3. 3 out of 5, sorry. 3 out of 5. Therefore, instead of computing all these possibilities whereby at least there is somebody who is late, somebody late, somebody late, you can see they are late, somebody's late, somebody's late, somebody's late, somebody's late. It is only this case whereby nobody is late. So to get probability that at least one will be late, it can be 1 minus probability nobody is late. Then the last part is at most one of them. At most one. At most one is going to be late. So at most one means where the person who is late is either one or nobody is late. At most one of them is going to be late. At most one of them is going to be late. So one of them going to be late. At least or at most one. At most one is going to be late. At most one is going to be late. So in the first case, the people who are late are more than one. So we exclude this. The people who are late are more than one. We exclude. The people who are late are more than one. We exclude. This is one of the cases because it's only this one who is late and we want at most one. This is another case which we are going to exclude since we have two people who are late. At most one, we have only one person here. In this case, the people who are late is only one. And in this case, there is even nobody, so they are below one. So it is the probability that we calculated about one of them is late plus this other probability of none of them being late. So the probability of one of them is late, and that was the probability of at least one, 13 out of 30, and the probability of none is late, which is 2 out of 5. Yeah, because it is those cases now. So this is going to be when we take 13 out of 30 plus 2 out of 5. This is giving us 5 out of 6.